Okay, let's talk about graphing those proportional relationships that we've been talking about for the last several pages. If a relationship is proportional, then it is also linear. Hopefully by now you understand what linear means. That is a straight line. Okay? The graph of this relationship would be a straight line going through the origin. And what is the origin? 0, 0. On the graph paper, create two patterns of your own. Well, I'll give them to you. One that is linear and one that is not linear. Label the example linear and not linear. Create a table of values. You must have at least 4 points. Draw the graph to confirm whether or not the graph is linear or proportional. For bonus, create a word problem to accompany your data. So let's do a linear relationship on the front. We have x and y. And let's say 0, 0, 1, 2, 2, 4, 3, 6, and 4, 8. Okay. And it makes a straight line. It crosses through the origin, so it is proportional. Okay, so for your bonus points, go ahead and try to come up with a word problem. You can't use this specific word problem, but for example, it costs $2 to rent a movie. How much does it cost to rent 4 movies? That's an example of a word problem that you could use. And so when you have your word problem figured out, go ahead and list your labels on the axis here. So you would say like number of movies and cost in dollars. But that's going to be up to you to do that word problem. Okay. And then we want to do a not linear example. If it's not linear, that means that it does not go up at a constant rate of change. Okay, so if we started at 0, 0, we're still going through the origin, and then let's say that we said it was $5 for your first movie, and then only $4 for each movie after that. Okay, so in this case, which sometimes you'll notice people do things like that in sales, like they'll say buy 4, get the 5th for free, or it's this much the first time you buy it and then you get a discount each time after that, or after so many then you get 1/2 off. So there's lots of different options there. So we have 0, 0, 1, 5, but then it goes to 9, and if we kept going then it would continue to go up this direction, and we can't draw a straight line that gets all of them. So my graph, and it's not extremely nonlinear because it only changes by 1. If this were to change by, if instead of 9 we made this 7, and then it would be 2, 7, then you could see a drastic change in the relationship. This has a rise of 5 and a run of 1, but then this section here has a rise of 4 and a run of 1. So you have to check. Just because it looks linear doesn't mean it is. That's where those stairs that we've talked about come into play. Okay? If your stairs aren't the same, then it's not linear. Okay? So this is not linear. Come up with a word problem. Don't steal the one that I used, but come up with a word problem and write it up here at the top underneath linear. Okay? Even though it contains the origin, that doesn't make it proportional. If it's not a straight line, it cannot be proportional. And then I will add a picture of some practice problems for you.